Good afternoon, everyone, and welcome to week 10 tutorial class.
Yeah.
So, today what we are going to do, we are going to, we have some leftover from the week 9. In the week 9 tutorial class, we have covered out of how many questions are here? Out of 11 questions, we have covered 6 or 7 one. So the remaining one, why not I have covered in the last tutorial because of the concept of hypothesis testing was like not clearly communicated to you, taught to you. That's why. So we have the leftover, so we'll try to finish that one first, and then we will move to the remaining one. So probably this tutorial will have more and more exercises related to the hypothesis testing. Keep in mind, we have just covered the single population mean. Even now, like even till this time, we have not covered single population proportion. So still, like we are on the single population mean. So let's go through like more and more exercises in this regard. Okay, so let's start with the exercise number 8. Some of the exercises like today, we'll do it on manually, and also we'll do it by using the Excel sheet. So keep yourself ready with the Excel sheet. It's better to sit down in the system where you have access of Microsoft packages. So, so let's start with the exercise number 8, and we will do this exercise together. What it says, exercise number 8. Yes, the question, this question contains both confidence interval as well as the hypothesis testing. So it's okay. We'll try to have both the section today, both the part of this exercise today. So what it says that listed below are the ages in years of randomly selected race car drivers. A random sample was drawn from a population that follows a normal distribution. Keep in mind the requirement. Whenever if you remember that we have the 5 stages for calculating the confidence interval CI estimation, whereas 7 steps to follow for hypothesis testing. So those 5 and 7 you just keep in mind. And in both cases, the first stage is a requirement, meeting the requirement. So in this question, it is clearly mentioned that the sample is a random selection, whereas the population, they exhibit normal distribution. That means for both the cases, the question number 1 and question number 2 here, the requirement part is fulfilling. I mean to say that that criteria is met. So how many, what is the sample size here? If you could count here, it is around 15. 1, 2, 3, 4, 5, yes, around yeah, 18. And what is the sample size? N equal to 15. It is mentioned in the question that using Excel, answer the following. So what we will do is, we will do using Excel as well. We will try to do it manually, because in the exam, you're not supposed to use the Excel sheet. We are not going to conduct the exam in the lab, unfortunately, because we are not having a face-to-face arrangement. So since it is online, so try to do it manually along with the Excel sheet. Using Excel, the first part is calculate the 95% confidence interval for the unknown mean mu. So using the sample statistics, we'll try to generalize it for the population mean mu. And the second part of this question is using a 5% significant level. So alpha value is 0.005. Test the claim that the mean value is of all race car driver, all the driver is greater than 30 years. We don't know what is the mean of the sample. But we have all the 15 data. So what we will do, first we will try to do it using the Excel. So what I will suggest you, just try to open our Excel sheet and take all the data, all the 15 data in your Excel sheet. I'm also doing in parallel. Okay. So all the 15 data I have taken here. Nothing is given, only the sample in terms of years. All the 15 sample, like all this 15 years, 15 data is given for the sample of years. You could see the count 1, 2, if you just see with the person. Yeah. So sample size is 15. So if it is sample size is 15, keep in mind your degree of freedom will be for a single population, it will be n-1, that is 40. What we are supposed to do, if suppose in case not manually you have to do it, suppose this sum using the Excel sheet. So what you wanted to have for the confidence interval, what you wanted to know? You wanted to know the mean value of this sample. You wanted to have a standard deviation. You wanted to have a margin of error. So recall which tools will give you those desired result. So if you go here, click the data, then data analysis, list of analysis tools are available. So what do you think? Which one will give you the mean, median, mode, standard deviation, everything? What do you think? It's a descriptive statistics. Yes, the descriptive statistics will give you the all those information. So just select the descriptive statistics. Okay. Then they are asking for the input range. Input range, just give the data values, all the 15 values. Enter. We are not using the labels, so no need to tick. Grouped by columns, yes, not the rows. Output option, we'll give the output option here over here. We wanted to have the finding over here in the same Excel sheet. Just tick these two. Summary statistics, that will give you the kind of information we are looking for. So tick the summary statistics. And confidence level, just tick the confidence level. Although in this question, it is clearly mentioned that the 90, you have to construct the confidence interval at 95%. Read the question. It's 95% confidence interval estimation. And also for the second part, 5% significant level, that means 95%. So it's better to write confidence interval 95%. If it is 99 or some other value, just change it and make it 95. And then OK. Pressing the OK button, you will get the descriptive analysis. Which gives you all the basics like sample statistics. These are known as sample statistics, not the population parameter. So sample statistics, mean, standard error, median, mode, standard deviation for our interest, curtices and all, range, maximum, minimum, sum, count, yes, number of sample sizes 15, yes, we have seen that, and confidence interval at 95%. Okay. Now, are you able to recall which one is like? So look at the question number first. Calculate 95% confidence interval for unknown unknown mean mu. So for 95% confidence interval, this is the Excel output. So could anybody tell like how to proceed further to calculate the confidence interval estimations? CIE. confidence interval estimation. ES. Wait. Huh. Can anybody suggest me how to proceed?
You have to find the degree of freedom and the corresponding value in the t table.
Okay, but you have given Excel sheet. That is the manual way, right? But think about here in this Excel sheet. Are you able to see the Excel sheet in front of you?
Yeah.
Now you think about, leave that manual way.
Okay.
But I said we will do it both in the both way. So try to, then you will have a profound understanding, in-depth understanding. So
all right.
Think about the Excel sheet. What data is given to you and how you will calculate the CI estimation. For the confidence interval estimation, you need two values, the mean value and
standard deviation.
That is the manual way. The final step, I mean to stage number 4.
Critical value.
Critical value is already Excel sheet has taken 95%. That input, that information we already fed. Stage number 4.
But you got confidence level on the Excel sheet.
Confidence interval.
Yes, yes, exactly. So what we have? But there are background noise. Let me see that. I could hear some of the sound. Okay. So what I was saying that we'll do it manually, but now just think about, if you're supposed to do this sum part A with the Excel output, what you will do, how you will go like proceed further. So which one in this column 1, which one you think is a margin of error and which one is mean?
So the mean 33.6 and the confidence level down there, do you like, is that the two numbers you pass and minus them together?
No. See the confidence level at the bottom. This is the margin of error.
Oh.
We have done this before. Just you have to apply your, think about which data is important for the answer. As I said earlier, the 4.2474 is the margin of error. This is the margin of error given by the Excel sheet. And this is the mean value. I mean to say, for calculating the confidence interval estimation, what you need? X bar minus E, X bar plus E, right? So this is equal to X bar. I'm clicking here, G6 in my column, minus margin of error.
Yeah.
This is the lower one.
Yeah, that's what I meant. I didn't know what I said. Sorry. That's what I meant.
Okay.
Like, yeah.
Yeah, it's okay, fine. If you are able to recall, I'm really happy. Go ahead with that one. And then the another interval will be upper level will be equal to mean plus your margin of error. So using the Excel, this is the final answer. You got the final answer. I mean to say, this is your final answer. Which interval? So the 29.35 to 37.885. This is the interval where the confidence interval estimation, and this is the answer. So this is the way of calculating the confidence like CI estimation using the Excel. Is there any doubt?
No.
Okay, just over here in exercise number 6, you see that there is a way of calculating confidence interval in Excel. Another way. Exercise number 7 is in front of you on the screen. If you see, there is a way of calculating confidence interval, CI. I mean, there is a way to calculate the margin of errors in Excel. Either you can do it using the strategies like this one, somebody statistics, descriptive statistics tool. Otherwise, you can use directly this formula, confidence interval, in order to calculate the margin of error. What it says that I'm going to use this one. There is a function known as confidence.t, and we will feed three different data. One is alpha value. Alpha value is given in our case 0.05. Standard deviation value will be taken from the Excel sheet, and the sample size in our case will be 15. Let's see. I'm using that one. So it says that confidence.t is the formula. So I'm just using here at the down, equal to, you can do in parallel, confidence, C-O-N, you will get confidence.t. Did you get that? Confidence.t. They are asking for three values: alpha, standard deviation, and size. So what is alpha value in our case? 0.05, 0.05. Standard deviation from the Excel sheet, from the top. You see the standard deviation is 7.66997 something. So if I can round up it, 7.6669, so 67, 7.67, comma, size. What is the sample size? 15, 1.5. Is this clear to everyone? This is a different way of, another way of finding the margin of error using the Excel. I fed three different data, and if you just put in enter, did you get the same thing which is above? Is this value is same as the margin of error above? I mean to say both are same or not?
Sir, I can't see the Excel sheet.
Oh, sorry.
Yeah.
You could have said to me earlier. Okay. I will do it once again.
Okay, thanks.
So, as I said, okay. Now you are able to see the Excel sheet. Okay.
Yeah.
So equal to, as I said, what is the direct formula you can, for calculating the margin of error? Confidence.t. Click that, confidence.t. They're asking for three different values: alpha value, standard deviation, and size. What is alpha value? 95% confidence interval estimation. So alpha is 0.05, 0.05. What is the standard deviation value? From the above Excel sheet, 7.66997. So with the round off, it will be 7.67, comma, sample size is 15, 1.5. Just feed these three values, make it enter. You see the margin of error.
Yeah.
You think both margin of error are same? Yes, both values are same. So this is a kind of shortcut to get the margin of error using the Excel. Okay, the first part is clear. Any doubt?
But I'm sorry, can you show us again the margin of error? I'm so sorry.
No worries, I can
Thank
repeat.
you. Thank you.
But are you able to see the Excel sheet?
Yes.
Okay. So
Okay.
I'm doing here, equal to confidence.t. Just write CON, you will get confidence.norm, confidence.t. This is a t-test, that's why confidence t.
Okay.
T-test for sample. So confidence.t, three different values: alpha, standard deviation, and size. So I'm writing alpha is 95%, so 0.05, comma, standard deviation from the Excel sheet 7.6699. So making it round up, 7.67. And then sample size is 15, 1.5. Feed all these three data and make it enter. You will get the same thing which is there, appears above. So both values are same. Did you get that?
Yes, yes, thank you.
Okay. So quickly move to the question number second, like second part of this question. Hypothesis testing. So 95% interval we have, we solved the, we got the confidence interval. Second one is hypothesis testing. Using 5% significant level, test the claim that the mean age of all driver is greater than 30 years. So let me stand up and use the whiteboard. Now I will use the whiteboard. So what information is, what are the information which are given to you? Okay, the 7 steps for the hypothesis testing. I'm just writing 1, 2, 3, 4, 5, 6, 7. 7 steps. First step is check for the criteria. So I'm sure you could see that condition has been met, right? It clearly says that the sample is drawn as a random sample, whereas the population is normally distributed. So in that case, the condition 1 is fulfilled. I'm just taking it as a fulfilled. What is the stage number second? Anybody? Hypothesis testing, all the 7 steps. The second step is, if I could remember, it is
Find the null and alternate hypothesis.
okay. Yeah, that is the like okay. So in this case, what is given? What is the claim? I'm writing here H naught and I'm writing HA, alternative. Claim is given. What is claim? Test the claim that the mean age mu for all the drivers is greater than 30 years. So mu value, I'm writing here, mu value is greater than 30. This is the claim. So what is the null hypothesis? Corresponding null hypothesis is, will be mu naught or mu equal to 30. On the basis of the question, I formulated H naught and HA. Let me know if you have any doubt. This is important. It clearly says that alternative hypothesis, the claim is the average age is greater than 30 years. So it's greater than 30 years. So over here we have to decide, is it one tail or two tail? Clearly, it's a case of one tail. It's a case of one tail test. What is the stage number 3? Define alpha. What is the alpha value?
0.05.
Alpha is like 95%, so 0.05. Then stage number 4. Let me open that slide. All the 7 stages. So I'm going through all these 7 stages one by one. Yes. So state null and hypothesis. Stage number 4 is calculate the test statistics. So again, this is the case of test T statistics. So how to calculate that one? Calculate that test statistics. So T stats. What is the formula for T stats?
X bar minus mu over.
Yes, you're right. X bar minus mu over
S divided by square root of n.
Okay, so capital S divided by
Square root of n.
square root of n. So what is the X bar? For this question in the part A, we have seen the Excel output gives you the X bar mean value. So how much it came? The mean value in the Excel sheet?
33.8.
Exactly. I'm writing 33.6 minus, what is the mu in this one? Hypothesis is 30. Divide by standard deviation from the Excel sheet, 7.67 or 6.67. It's a 7.67. Standard deviation is 7.67. The standard deviation of the sample, capital S, not the sigma. Divide by 16, or what is the sample size? 15, 1, 5. Try to calculate T stats using this one. Because T stats calculation will lead you towards the calculation of the P values. And P values will help you to take the final decision, either to reject or accept the, or to reject or not to reject the null hypothesis. So take your own time and find out what is the T value, T stats value. I'm going to say it's 3.6 into square root of 15 by 7.67. What is the T value?
One 1.8346. 8346.
Okay, so T starts value is coming 1.8. Probably it will be 1.818 or just cross check.
I got 1.8178.
I
Yeah.
think so. So this is more closer. Yeah, I think Betty, could you check and confirm? There is a slight difference in your answer. You must get somewhere 1.818. The calculation, you can do it once again and you just cross check. I'm sure like there will be maybe there is a issue of rounding off, so of root 15 or somewhere. So just anyway, there will be not much difference, but try to have this number close to this one, because someone else is like getting 1.817 something, so it's like more close to the one, this one.
Yeah, I'm getting that.
Yes, others, if you get the T stats value, what is the next stage? The next stage is to get the P value. Okay, I think okay, let me tell you one thing. How to get the P value? Using the table.
You have to get degree of freedom.
Okay, so what is the degree of freedom here? I have it right here. Since n equal to 15, so degree of freedom is 14. So go back to the T stats table. Let me open that T table for you. Where is that? Some background noise. Okay. Okay, we have the degree of freedom 14 GOF. So what I'm doing is I'm using some drawings here. Okay, so degree of freedom is 14. So taking the horizontally 14 and T stats is 1.818. So I'm trying to see the closest one with the 1.818, the closest number of for compared to this one, 1.818. So let's go horizontally. 1.818. I think 1.761 is closer to the closest one to the 1.1818. And if you go vertically up, you get that value 0.05. Did you get this number 0.05?
Yes.
Something is wrong, or are we missing something? Okay, 0.045. So 1.761 and 1.18. So probably it will be somewhere in between these two. Why there is a issue, you know? Sometimes it's like this one, because the next step is we have to calculate the p-value with the value of alpha. Alpha value is also how much? 0.05. So there is a, you know, situation where you have to be more careful how to take that final decision. So what I'm suggesting you here is a bit critical, but anyway, we'll try to sort it out. So what I'm saying is T stats 1.818. T stats 1.818. So in that case, T values lies between, I'm writing here, T values. Okay, let me first write 1.761, and then you have 2.145, 2.145. And what is 1.761 is 0.005, and this is 0.025. Okay, now I'm switching to the board, whiteboard. Yeah. Okay, you see what I did is there is a critical issue over here in terms of making the decision, and a little bit you have to be with me to understand why this is the case of confusion. Because if the way we are doing, we did previously, if you take this one and finding the closest one, you will get the critical value 0.05. And the next step is you have to see that p-value has to be either less than 0.05, or p-value either has to be greater than 0.05. And based on that, we make the decision regarding either H0 reject or H0 not reject. Is that clear?
Sir, I think it's 2.145.
Which one?
The value of 0.025 at 14, it's 2.145. You put 2.45.
Okay. This one?
Yeah.
It's okay, fine. It's okay. Thanks for correcting. Okay. Okay, 2.145. Okay, fine. So what is important here? Over here, if I just take 0.1818, closest 1.05, there will be a confusion in terms of making a decision, because you won't say that 0.05 is less than 0.05. So what I did is I took it bit in the broader sense here. What I saw that in the table, the T values lies between, T values is 1.8, lies between 1.76 and 2.14 in the table. And what is the corresponding value? For 1.76, you see the probability value 0.05. And for the next one, 2.145, you will see that 0.0025. In exact sense, your T values lies in between these two. So what do you think? This T value is less than 0.05 or not? What do you say? Is the real T value will be less than 0.5 or not?
No.
Sure? Because the T value lies between 0.05 and 0.025. 0.025. So I think if you could see that the T value, that means the T value itself will be smaller than or lesser than 0.05, because it says that the T value says that the T is in between these two values. That means the T value is lower than 0.05, and that helps you in making the final decision. That means in the graph, you have the t-value 1.818, and this area, probability area, we are trying to. So this area will be less than 0.05 from here, because the another end is 0.025. So somewhere in between the t-values is there. So t-value will be must be less than 0.05. Since t-value is less than 0.05, what is the stage number 6? What is the stage number 6? You need to take decision regarding rejecting or not rejecting H0.
Wait, sorry, sir. So what's our final p-value? 0.025?
No, see the point, it's difficult to calculate final p-values, but you have to make an assumption that where is the t-value?
Okay.
See, the table is, does the table give you the exact value?
Yeah,
No.
no.
But it gives you the range.
Yeah. Okay.
Means the t-value, this is important because in the previous questions we haven't faced this sort of, it was very clear that p-value was less than 0.05
Yeah.
and we were moving with the direction like decision. But
Yeah.
over here there is a confusion. It's difficult. If you take
Yeah.
that 0.05, is it a less than 0.05 or greater than, it's difficult to say. That's
Yeah.
why I took the complete picture.
Okay.
And it
Okay.
gives that the t-value will be somewhere less than 0.5 because in this range. That
Okay.
gives you the clarity that your t-value is, or your p-value is,
Excuse
that gives you the stage number 6, that p-value is less than 0.05. That means if p-value is less, what is the decision?
excuse me.
Yeah.
On the slides, there is something talking about the p-value, and it says if something is a right-tail test, then the p-value will be the area to the right of the test statistic.
Yes, you're
So
right.
we should be taking our p-value as 0.025. It's the one to the right.
No. That is another one. What you are saying is, I got your point and I understand what you are saying. I'm able to draw this side. Okay, let me draw this side. The arrangement in the house is like a bit different, so that's why. What you are saying is that is different thing. The final area. If I'm able to draw here, this is the t value. What is the t value exact? 1.818. And this is the t value 0. It's just like mu value 0 and mu value, we did it before. And they're saying that we need to consider this area right to the, this will give the probability value. But exact probability value, it lies between 0.05 and 0.0025. So it may be somewhere just less than this. How much it will be? 0.049 or 48 somewhere. But it won't be 0.05 exactly. Are you getting?
Yes, yes.
So that probability value is different one. The calculation is over here in this graph, not over here. So we can't take this one. Always we have to take which one is the closest one. If out of these two we have to take the closest one. Which one is closest from 1.8? It's 1.76. We should not take this one. We should take this one, the closest one. And if there is a kind of the difficulty in terms of this question, just like this question, then you try to see the broader picture. Try to see the which is the actual range of varying the probability value. So the probability value, it varies somewhere in between 0.05 to 0.0025, and it means the t value will be less than 0.05. Based on that, you make the decision in the stage second, in the step 6, and that means the H0 must go. That is the decision. In the stage number 6, p value is less than 0.05, so H0 must go. So reject H0. That is the stage number 6. We'll do the same exercise using the Excel sheet and we'll verify are we doing good or not. So what is the final stage? Conclusion. So H0 is rejected. We can say H0 is rejected because the p-value is less than 0.05. And the second sentence will be the population mean is, so we found what? H0 is rejected. Means we found evidence for the mean value of the age of the drivers is greater than 30. That is your final conclusion. Just let me know if this thing is not clear. Anything is not clear in this sum. And we will do the same sum with using the Excel sheet as well. Over here in this case, while doing the manually, what we did, we reject the null hypothesis, isn't it? And you want to see what is the exact p-value. Excel will give you the exact p-value. Let's do it on Excel. Somebody asked like, what is the exact p-value? I'm saying that it will be somewhere in this range, this is 0.05 and 0.025. But what is the exact p-value? Excel will give you. Let's see. Can we do it now on the Excel? Open the Excel sheet, the same one. Sorry. Okay. So the first part we have done using the Excel. If you could remember, this is the case of t-test. And last time I said that there is in the Excel, you don't have anything like the t-test for a single population. Are you able to recall? You see the t-test, pair two samples. All the t-test tools which are available in the Excel, it is for the two samples. But we have in our case, it is a single sample, right? So what is the trick? I suggested you that we can use the same thing with the trick. What is that trick? Are you able to recall? We have to take the second sample with the 0, 0, 0. So what I took the second sample with the 0. I'm just deleting this one because I hope the confidence interval you understood. I'm just making some free space so that we have the second report. So what is the next one? What I will do, I will go again in data analysis, and this time I will select. Are you able to see the Excel sheet now?
Yep.
Okay. So which one I will select? The t-test two sample assuming unequal variance, not the equal variance, because one is I have taken at randomly 0, 0, 0. So the variance will be, of course, was one sample and another sample. The variance will be different because in the first one we got the sample variance 58.82. Another one the variance will be 0, 0, 0. So maybe 0. So it's unequal variance. Select that one. Okay. Asking for two sets of data. So first one, you just give the real value. In the value 2 range, just assign. I think I did some mistake in the first one. Let me check. Let me go. I should select each one, all the 15. Now it's fine. For the range 2, let me select all 15. Okay, all good. What is a hypothesized mean difference in this case? Any idea? What should be the hypothesized mean difference? Check the hypothesis. What is a hypothesized mean difference? I mean hypothesis, check what is the mean value. They are asking for the hypothesis mean or population mean. How much it is in this case? For this sample of data, what is the hypothesized mean? The real mean is 33.6. What is the hypothesized mean?
30.
30. So we just put 30. Alpha value. Is it 0.05? Yes. In this case, we are looking for 0.05. Testing is for 5% significance level. So 0.05. Keep the output range in the same place over here somewhere so that you can see. And then press OK. Some of you, someone of you wanted to have exact value of P. You have in front of you. So if think about, if you using the Excel, you could think about solving this question. So what in that case, what you could have done? How much the T state value we get? We get it manually. Is it the same? 1.818?
Yeah.
Yes.
Yeah.
And which one we have to take? This is the case of one tail because the mu value is greater than 30. So what is the mu value? What is the P value for one tail? Did you get the answer? Exact P value?
0.04, yeah.
Exactly. Does it lesser than 0.05?
Yeah.
And that's what we were asking on the board.
Okay. Wait, so sir, if you're doing it manually and somehow your your P value comes out the same as your alpha, so what you have to do is you have to paint the whole picture.
Exactly.
So like the T value in the range of the T value, and then you have to choose the side that has like that comes nearer to the actual value. So in this case, the 0.05 was near. That's why we chose T is
Exactly.
less than 0.05. Okay, got it. Thanks.
Exactly. So probably in the question, one part will be asking for the T stats value. In the question, it won't be that what will be the P value. You will have the what is the final decision. So final decision is H1 is rejected. So over here also the P value is, I can write here less than 0.05. So basis on this one, H0 rejected because the P value is less than, so H0 is rejected. So that's what I was telling, that you can do it using Excel. If it could be a one tail test, then we could have taken another P value 0.090. Is that clear to everyone? Because this sum we have done it using two different way. Where is the sum now? Okay. So exercise number 8 is clear now to everyone. Otherwise, just let me know if you have any doubt. Just stop me. I could see in the chat box there is no such thing that not clear. So I'm moving ahead. So now we'll take the next sum. So 8 is clear. Okay. Exercise number 9 is the blood volume of sample. I think we did it using the Excel sheet in the previous class. So that using the test statistics, we try to see the claim, 99% claim, and we have done this one using the Excel sheet. So exercise number 9, we have done it before. So no need to repeat that. Then we have exercise number 10 and exercise number 11. In exercise number 10, we have different sections, different parts. So let's go through one by one. Exercise number 10. A claim that the population mean for the adult female white blood cell count is 8.0. A random sample of 40 female adults have a white blood counts and with the mean 7.15 and the standard deviation is given. You need to calculate the T statistics. All these are like exercise 10 is like a small sum. So you just try to do it. It will be easy. Just make a note of what is given and then you just apply the formula. Since red is not proper one. Okay, what is given? Do it quickly because we're a little bit slow, more slow today, but anyway. So 10 first A. What is given? A random sample of n equal to 40. Sample mean is given. So x bar is given 7.15. Standard deviation capital S is given 2.28. Is that visible to you? Let me change the mode. Yes. 2.28. And the population mean is given. So mu naught is also given 8.0. Find the T start. So T start is x bar minus mu naught S divided by capital N. What is the value? X bar is 7.57 minus 8.0 divided by capital S 2.28 divided by N equal to 40, right? N equal to 40. What is T start's value? Could you get it? Get this number? Get this number. Try to get this number. Let me know what is the T stats value you're coming up. Anyone?
Negative 2.3578.
Okay, so minus 2.3578. 78 means round up it, make it 8. You are right. Minus 2.358. Others try to match this answer. The T value, T starts value is minus 2.358. Remember, this is the first time we are solving, we are getting any T values which is negative. We have seen in the earlier example, whenever we did, the T starts value was coming positive. But this is the negative time. This is the like negative value. Did you get this number, everyone?
Yes.
Okay. You see the interpretation. I think I haven't taught you how to interpret the negative value. As I said, the T stats or the Z score value, almost both are the bell set, right? Try to understand this, and this is a bit conceptual here now. What I said is like over here, T equal to 0, just like the mean value was 0 here. Recall, I was writing here all the time mu equal to 0. The same way T equal to 0. And all this horizontal axis has the T value, different T values. So whenever we used to get the T value as a positive, we used to write the right side and we used to see the right area in order to calculate the probability value, P value. But this time we are getting negative values. So that means somewhere the T value is here. Minus 2.358. Because in between middle is 0. So positive will go right side, negative will go. So somewhere I'm assuming that this is the T stats. And they're asking for calculate this area, the P value. This will give you the P value. Since this curve is well shaped, so exactly this is the mirror image on the right side. So if I was saying that if there is a point of T stats minus 2.358, there is a T value, it means there is a corresponding value, the same value on the right hand side, that is 2.358. And the area for this one will be the same as area for this side. So this value and this value will be same conceptually, because it's a mirror image. It's exactly the bell shaped, which is the symmetric in nature. So this area will be exactly same if there is a T point 2.358. And what is important here? You will see the T stats, T table. Do you think that any negative value is t stats for negative value is given? Check the t stats table.
No.
Why they have not given? Because whenever you have -1, there is an assumption that just take it to the right side and calculate the p-value. This is conceptually important to understand. If the t-stats value is positive, you are able to calculate it straight away with the table. But what will happen if it is negative? So if it is a negative, you have to assume that you have to calculate this probability of this area, right? So there is an exact mirror image on the right side with the same t-value. And since this is a positive value, the t-stats give you the value. So what is the t-stats value? Like, can you get the p-value here for this one? Just try to get it with this. What is the what is the number of freedom? 39?
39. But sir, the table doesn't have 39. It's like
Okay, there are lots of issues. That's why. I don't know why this is the case. I have one book. This is a well-known book. Very like across different university in the world, they use this book.
Is this going to be an exam?
What?
Is this going to be an exam, like something like this? So confusing.
No, it's not confusing, but there is a way. See, if 39 is not given, just take the 41. What I said, you have to take the closest one.
so 40. We work with the degree of freedom of 40.
Yes, exactly, because the 39 is not given. But fortunately, I got one table in this book in which you have it is given exact value. I'll show you that one. This table also. Today only I noticed this one. Keep in mind, you have to assume it because we are using the Z table or T state table. So whatever information is given, we have to just use that one. If 39 is not given and 40 is given, just use the 40 because the value will be closest to that. But since I got this value, I wanted to share with you. Just wait, where is that? Two different PDF. Yeah. And I will share this one, this table also. I think I already shared on the Moodle. You can download it under the announcement. Today only I shared after uploading.
See? Yeah, I think you sent that one to us.
Yes, already I shared with you. You see here, in this one, it is clearly given all the values, 34, 35, 36, 48, 59. It's very rare. Even I was trying to get the 1 to 100 on online, Google. I tried a lot, but I didn't get this one. And it is, fortunately, it is given in one of the. So over here, you see the 49 is given. But you see, if 49 is not given and 50 is given, oh no, sorry. If 39 is not given and 40 is given, see the change, how much is the changes in the value? For in this case, what is the probability value for using this table? Suppose the t-stat is coming negative 2.358. So corresponding positive is 2.358. Which one is 2.358? Which one is closer? 2.4?
Yeah.
So you see the 2.433 for the 40, whereas for the 39, it is 2.4258. How much is the difference? Negligible. Negligible, 0.0025. It's very negligible difference. That's why you just go ahead with the 40. Although you keep in mind you are looking for 39, but the data is not given. So then what you will do? Just take the closest one. Statistics are all about the assumption. So if you're saying that this is close one, argument is clear, argument is right. So nothing is wrong in that. Whatever the data you have available, you have to make a best assumption using that. So now I already shared this one. I will suggest you to use this one. Keep this one also with you while sitting in the final exam, or maybe just keep it because it's very rare. It's not available. The data, even you can search, you won't find the exact 1 to 100 for the t-stats value. But I got it, so I thought share it. But okay, now go ahead with this one. Even you can use this one or the older one. So what is the p-value corresponding to this question? Could you tell me what is the t value for this question? Because why I'm asking for the t values, I added another one over here is t stats.
0.01.
Yes, let me open that question for you once again. Okay, so this question, calculate the t statistics, we got minus 2.358. That is over. That part is done. But the second part is test this claim at 5% significance level. So can we do it? What is the alpha value here? Test this claim for 5% significant level. The same question. So what is the alpha value? 0.05. So if there is a case of testing the claim, so it means you have to find the p-value now. What is the p-value? For 39 degree of freedom and t-stat is minus 2.358. So if it is a minus, keep in mind, we just have to transfer to the right side. So the t-value here in the right side, to find out the probability value. And keep in mind, is this a one-tail test or two-tail test? The claim that population mean for the adult mean is count is equal to 8. So if it is equal or not equal to the case, it is a one-tail or two-tail. It will be a two-tail because I'm writing here H0 and HA. If HA is, the claim is mu value is equal to 8. Mu is equal to 8.0. So what is the H0? Mu value is not equal to 8.0. So that means it is a two-tail test. Two-tail test. That's why we got the values negative. So there is a probability here and one side is here. So if it is a two-tail test, try to get the p-value. What is the p-value using the table? So okay. Let me have some drawing here. Two-tail test, yeah. So 39. I'm drawing here 39 and just taking it horizontally. What is the value? 2.358. 2.3. I think this is closer. This value is closer. 2.4258. And then we have to go and find out the corresponding value on the top. Just do it.
0.01.
You will get 0.01. Yes, you're right. Even you can use the older version of our t table. You will get the, let me open that one also. You will get the value 0.01. Yes, you see here in this one, even if I'm assuming that 40, suppose that in this one I have 40. So instead of 39, I'm assuming that it's 40. So if you go horizontally, try to see the 2.3. So 2.3 is closer to 2.4. 2.423, and horizontally you will get the value. What value? 0.01. So what is the final p-value? If it is a two-tail test, what is the final p-value? It's a one time or two time? If it is a two-tail test, it is a two time of the probability value. So 2.2 into 0.01. So 0.02 is the p-value. Point 0.02 is the p-value because it's a two-tail test. So we got, see, using the table, we got this area, how much? 0.10. And also in this side, left side, we have 0.10. So what is the total probability? 2 times 2 into 0.10. So the probability value is 0.02. And since the probability value is 0.02 is less than the alpha value. 0.05, H naught will be rejected or not rejected?
Rejected.
Exactly. So reject H naught. H naught reject. Just let me know if anything is not clear, because we have other exercises which will make you more and more clearer. But this one is okay. This is the case of two tail. That's why we multiplied with 2. In the previous case, it was a one tail. So we haven't multiplied. We have just kept the one area. It was the right tail. So right side tail. So we use just 1 into that probability value. But in this case, it was a two tail. So it is a 2 times the probability value. Any doubt? If any doubt, then just use the chat box for the indication. Otherwise, I will move to the next question. That is a part B. I think the B, C, D, all these parts are like quite easy.
Why did we say it's two-tail?
Yeah.
Why is it two-tail?
Why it is two-tailed? Because you see the claim. What is the claim? The population mean is equal to 8.0. So the contradiction will be the alternate. This is the alternative one, H1, H8. Alternative one is saying that mu value is equal to 8.0. So the null hypothesis will be mu equal to not equal to 8.0. Remember, claim is important. What is the claim? If it is equal to, then the null hypothesis will be not equal to. So it probability, you have the two different types of side of probability. It's a two-tail because it's not saying one-sided. It's not lower than or up, greater than. Because see, in the previous question, question number 9, we saw that it was clearly mentioned that it's lower than. But over here is like not lower than or the greater than. So you have to go ahead with the two-tail. But if the direction is clear, lower and upper, then it will be one tail. You see the question number B, C, and D. What it says, 10, B, C, and D. Is it a one tail or two tail? Just have a quick review.
One tail.
Exactly. You see all the question number B, C, and D. It's a one tail. The one direction. Mu is greater than 1.10. Mu is greater than 20 mg. Mu is greater than 475. What about the question number E? Any other? What about the question number E? Is it one tail or two tail?
Two-tailed.
Is it not equal to? So you're not sure it's lower or higher. Blindly go ahead with the two tail. So with practice, more thing will come. So just try to have and just try to attempt the B, C, and D. All three questions looks very similar. I think you will get the answer very quickly. Try for the B, C, and D first, then E, remaining one. So for the B, what is given? Test the claim for the nicotine accounts in the cigarettes. Mu equal to greater than 1.10. Sample size n equal to 25. And T starts is 3.349. Let's do it using the Excel sheet. Or do it manually. Both we can do it. Use the table and tell me what is the p-value. See, the t value is in this case positive, and positive value you have given. And what is the degree of freedom? 24.
24.
Yes. So using the table here and see that I'm drawing
0.001.
So 24 is here, and t value is 3.349. So 3.349, 3.34. I think it's closer to here, 3.3467. So it's close to this value, 3.467. So what is the corresponding value you will get?
0.001.
0.001. That is the answer for the p-value. But can we do it using the Excel?
Wait, sir, how would you know if you reject whether to reject the null hypothesis or not? There's no given alpha value.
Oh, in this case, in the first A part, I just introduced, I added that question. You are not supposed to get, because this is not the complete question. So you don't have to reject and all.
Yeah. Okay.
Okay, don't worry. This is a small fraction of the questions. It's a kind of MCQ.
Got it. Thanks.
It's not one. You need to have a complete data, complete information to take the. So I tried to mold the question number A, part A only for the hypothesis testing. So I added only one line there, that can you find the test this claim for the 95. Otherwise, if not much data is there, don't forcefully try to. Okay. Can we do this one? Can we can we do this one using the Excel? Can we find the p-value using the Excel? Using the manually, using the table, we got 0.001. Can we do it using the Excel? Yes, do it. I'm here. Okay, doing it here. How to do this one using the Excel? Any idea? It is given in the over here. You see, in the exercise number 9, finding the p-value using the formula. So what is the formula here? T dot dist. Note it down. But anyway, this won't be a part of exam, but just for your learning. If you use the T dot dist, T distribution, it will give you the p-value. It says that. So you have 3 different ones. T dist, T dot dist. You use this one, T dot dist. If it is a left tail, keep in mind, note it, make a note. Use T dist if it is a left tail case. Otherwise, for the right one, use the RT. And for two tail, you have to use T dist dot 2T. Make a note of this one. And then, so what do you think? The question number B, is it a left tail or right tail? Which tail? Question number B. Part B, I mean to say, 10, part B. Is it a right tail or left tail or two tail? If something is greater, greater means right. So in that case, we will use RT. So see on the Excel, I'm trying to get the value using Excel. So any cell, just pick up and write down equal to T dot dist. Yeah, you see all 3 came. T dot dist, T dot dist dot 2T, or T dot dist dot RT for the right side. So this is the right one. So I will use the T dot dist dot RT. And they're asking for 3 values. X, no, 2 values, X and degree of freedom. What is X? X is the T statistics, 3.349. 3.349 is given, the T value. And what is the degree of freedom? 25 is the size, so 24. Close this one. You see how much you got? 0.00134. Using the table, how much we got? 0.001. You see, both are same. This is using Excel, and this is using table. Is that clear?
Yes.
So you need to just have to master in terms of. So did you get the p-value for B? Yes, 0.0. Okay, do it for the same, do the same thing for the C and D. I'm writing here on the board. Answer. Use the table. You know how to do it with the Excel, so just use the table. Find out. So what is the p-value for this one? We got it 0.001. For C and for D, B. Okay. For C, you will get how much is the, try to get it for the C. I'm writing here. For C, you will get, using Excel, if you will use the Excel, you will get 0.0479. If you use the table, you will get 0.05. For the part D, if you use the Excel, you will get 0.018. Otherwise, with the table, you will get 0.020. See, the almost all are same. For the part E, Excel. We'll do the part E. Just make a note of part B, C, and D. Remember, in the part D, what it says, it's negative t value. T value is negative. So again, convert it into the positive one. Look for the positive 2.242 for the freedom, degree of freedom 20 for the part D. For the part E, just try to do it the part E together. I'm erasing here. Part E is, the claim is that the pulse rate is not equal to, mu is not equal to 73. So this is the case of two-tailed test. Clearly. We'll try to do it both using Excel and using manually, and we'll see that is the answer is coming same or not. So as I said, what is given? N equal to given 40. So degree of freedom is 39, and the t value is given 2.463. Find out the p value using the table. You have table, find out the p value and tell me how much is coming. This coming. Use the table and tell me. Remember, this is the two-tailed test.
0.01.
0.01. But what is the p value? Final p value?
0.02.
Exactly. So using the table, I'm writing here, using table, it is 2 times, it's a right side, probability on the right side. So the table is giving you 0.21, 0.01, right? 0.01. So the final probability value is 0.02, isn't it?
Yes.
Okay, let's do it quickly on the Excel sheet for the same. Using Excel sheet over here in front of you, I'm using what is the t dot. In this case, it is 2t. So I will use t dot dist dot 2t. So click that one. They're asking for x value and degree of freedom. What is x value? I mean t value 2.463. 2.463, comma, degree of freedom is n is 40, so degree of freedom is 39. Did you get the same thing? Yes. So using the Excel, this is using table, and this is the Excel is giving you how much? 0.0183. Excel is giving you 0.0183. See, both the values are same. I mean, your analysis nowhere is going to change if you're using Excel sheet or using the manual. I think you guys are fortunate. This interim exam, you don't have to use the Excel sheet. Otherwise, taking the exam in the Excel sheet mode could have been a bit more tougher. But anyway, just try to keep learning in parallel. Is that clear, E part?
Yeah.
Any doubt, you can ask. Otherwise, I will move to the exercise number 11. Anyone? Badr? Are you there, Badr? Badir. I'm sorry if I'm not able to pronounce it properly. Badir, are you here? TJ, are you here?
Mr. Ahmed,
Yes.
it is time for like eating for us. It is Ramadan.
Ah, I'm
So
sorry.
can we have a break?
Okay, how much you? 5 minutes or 10 minutes?
8 minutes, yeah, 10 minutes, like enough.
Okay, can everybody, can we take like after 6, it may go 6:30. Is it fine for everyone? Because everybody is sitting in the house. I hope everything will be fine for.
All right, thank you.
So do we go for 10 minutes break? Okay, please go ahead. So, okay, 35. We will start by 5:35. Sultan, we will start by 5:35.
Okay, thank you.
Okay. So others, please have a respect and just go for some small break and come back by 5:35. I'm putting it pause here. Okay, now it's starting. Okay. I think the previous question I haven't recorded, so just be careful. I missed it out, but. So the confidence interval, what is important to keep in mind? T alpha by 2. So again, carefully we have we analyze the value T alpha by 2 that comes around 2.131. S was given, N was given, so you found the margin of error and then finally the confidence interval. X bar minus E, X bar plus E. X bar is given 360. So finally you got the interval of 2 to 3.62 to 496.38. So you could say that we are 95% confident that the interval this to this does contain the population mean of NEAT. So whatever is the question. Is that clear?
Yeah.
Okay. So one thing is remaining here today, which is not being covered, that is proportion. So I have till now whatever we did for the hypothesis testing, we have done it for one single population, and that is for me. I have one small case for the proportion. So quickly we'll go through that before closing today's session. I'm available on this Saturday and Sunday coming weekend. So let me know whenever you need any time. Fortunately, now internet is working in my house, so there is no problem. So I can allocate any number of hours if you have any issues. So just let me know as usual.
So our test is on Monday, right? Hypothesis testing?
No. This Monday there is a no test.
On next Monday.
Yes. On the confidence interval, we have a test next Monday.
Okay.
So, I mean, next to next Monday. Means coming Monday, there is no test. After 2 days, I mean, today is 1st. So, there is no test on 4th of May. The test is on 11th of May on the confidence interval. Okay. So JET test for the single population mean when sigma is known. Till now, whatever exercise we did for the single population, what we have understood that the sigma value was not given. I mean to say the sample statistics were given instead of population standard deviation sigma. But sometimes you will see that the sigma value is given. So for that, how to proceed with the hypothesis testing? So that for that, like we have JET test for the single population mean when the sigma is known. Sigma is the population standard deviation. So if it is known, we have to apply Z test for the hypothesis testing. Whereas if sigma is unknown, we have to apply T test for the single population mean hypothesis testing. So let's go ahead with this one, and it's easy to understand. We have to follow the same 7 steps. Only we have to, instead of T stats, we have to find Z statistics or Z test or Z statistics. Almost looks similar, right? The T stat was X bar minus mu divided by capital S. So instead of capital S, we have to use the sigma value. I think with one example, it will be clear for you. So in the Oxford serial case, suppose that the sample of the 25 serial boxes indicate a sample mean X bar 372.5 grams. I mean to say, like the manager, they have to randomly they have selected 25 boxes, and they found that the sample mean is given X bar 372.5 grams. But apart from that, in the question itself, it is mentioned that the population standard deviation sigma is 15 grams. But before that, the previous question, we have seen that even the sample mean was given, the population standard deviation sigma was unknown. But in this case, population standard deviation is given. That means you don't have the sample standard deviation. It is not given. So either you have to give, it will be given sigma or capital S. So in this case, sigma is given. And what is the claim? A claim was made that the mean is different from 368 grams. So can we formulate all the steps or the major steps? Let's see. You remember, this is a different case where sigma is known. So let me quickly note it down. What information is given? X bar is given 372.5. Sample size n equal to 25 given. Population standard deviation sigma is given 15 grams, 15. And there is a claim that population is, the mean is different from 368 grams. So what is H naught? I will explain once again, but let me write here first. H1. Claim is mean is different. Mu is different means not equal to 368. And we need to claim this one at alpha value, significance level 0.5%, significance 0.05. Switch to the whiteboard now. So see what information we are given. X bar was given 372.5. Sample size 25. Standard deviation, sample population standard deviation 15 grams was given. And the claim was made that the mu value is not 368. If it is not 368 means, claim was made that it is different from 368. Different means it is not clearly showing that it is lower than 368 or more than 368. So in this case, it is a two-tail test. So mu not equal to, different means mu is not equal to 368. So if that is the claim or alternative hypothesis HA, what is null hypothesis then? Null hypothesis will be mu equal to 368 grams. And since it is a not equal to sign is there, so it is a two-tail test. But calculating the p-value over here is the different way. We have used the t-stats table for calculating p-value in the previous case, but over here we have a different way of calculating p-value, because ultimately the p-value gives you the clear decision. Is it H0 rejecting or H0 not rejecting? So remember, this is the Z case. This is the Z. So what is the next step? As I said, it's a Z case. Z statistics we have to find out. So once you formulated null hypothesis and alternative hypothesis, next step is find the Z state. Z statistics. So you have the formula x bar minus mu divided by sigma square root of n. Find out. What is x bar? 372.5 minus mu value or mu naught value. So 368 divided by standard deviation is given 15 divided by square root of n. N is 25. Square root of 25. Find out how much is the value. So this is 4.5 into, it will go up, so it is 5 divided by 15. 5 plus 3, so 3. 1.5. Did you get the Z stats value 1.5?
Yes.
You got the Z stats value 1.5. So what is the next? Since we are not using the T stats, so it was easy to go through the T stats with degree of freedom, but we will not talk about even the degree of freedom. The concept of degree of freedom only applies for the T statistics, not for the Z statistics. So over here, there is a different way of making a decision or calculating the P value. So over here, we will talk about the area of rejection and area of non-rejection. So there is a bit different way. I want you to just have a more focus. So you understood how to calculate the Z statistics. The formula is the same as the case of T stats. So just we have to replace capital S with the standard deviation sigma. So Z score came 1.5. Now, what is next? Next step is to find out the P value and make the decision. Probably I have discussed the area of rejection and area of non-rejection long back. Let me repeat here once again. There is an area of rejection and area of non-rejection. That concept is here. If I'm saying, what is the Z value for the 95%?
1.96.
Exactly, that is important here. You will see that in the bell curve, there is minus 1.96 Z stats or Z value, or this is 0 and this is Z value 1.96. These two area is known as, these two area, outside area is known as area of rejection, area of rejection, whereas inside these two, are known as area of non-rejection. This is a different way of making the analyzing the P value or the making the final decision. So outside area, these two are area of non-rejection, and inside area is area of, outside is area of rejection, inside is an area of non-rejection. For 5%, you remember what is the Z value? 1.96. For alpha 0.5, you will get the value 1.96. Okay. In this case, Z stat value, how much we got? 1.5. So 1.5. So these two are 1.96 or minus 1.96. These two are the critical value. These two are the critical values, CV, critical value. Now in this case, Z stats value is 1.5. So 1.5 is somewhere here, 1.5. and 1.5, this value falls under the area of non-rejection. Area of rejection means we will reject null hypothesis. Area of rejection means reject H naught. Whereas area of non-rejection means we will not reject. Over here we will not reject H naught. So since Z stats value is 1.5, it falls under the area of non-rejection. On the basis of this, we'll make a final conclusion that we should, over here it was rejecting H naught, area of rejection. So we should not reject. So non-rejection of H naught. That is the conclusion. It means we should not reject the null hypothesis H naught. So we found no claim for the mean value different from 368. So area, the mean value is still 368. Let me know if it is not clear, because where is that one? Okay. Okay, in the left side diagram, it is clearly given that for 95% confidence level, or so for 95% significant level, what is the alpha value? 0.05. So alpha by 2 will be 0.025. And if you see the Z table, you will see the corresponding Z value at 0.025. It will be 1.96. We did it long back. The same way in the left tail also it will be minus 1.96 and the corresponding area will be 0.025. So we got the critical value as a plus minus 1.96 for the 95%. For the alpha value 0.05. 1.96 will change to 2 point something, 3 or 4, 5 something if the alpha value will be 0.01. Or it will change to 1.65 if it will be, the alpha value will be 10% or 0.10. So you need to consider that one. You need to keep that one in mind. We already did, we know that how to calculate the critical value. We did it earlier. So in this case, for 95%, critical value is 1.96. So minus 1.96 to 1.96. But the Z stat value for after the calculation, we got 1.5. So you need to decide, is it falls, the value Z stats value is that fall under the area of non-rejection or area of rejection. So clearly 1 point plus 1.5 is lower than 1.96. So the final decision will be what? Reject H naught if it is a greater than, that is area of rejection, or Z stat is lower than minus 1.96. Otherwise do not reject. So in this case it falls 1.5, it falls under the region of non-rejection. So we should not reject null hypothesis. So that is the final point over here. It is mentioned because Z value plus 1.5 is in between somewhere minus 1.96 to plus 1.96. You should not reject H naught, non-rejection of H naught. You continue to believe that as a manager, you continue to believe that the mean fill amount is 368. I mean, we didn't get any claim for the alternative one. It means we need to, as a manager, we continue to believe that the average weight amount is 368 grams. So you state the conclusion as there is a insufficient evidence that the mean fill is different from 368. So we didn't find any empirical evidence for that. Or there is we could say other way, there is a sufficient evidence that the mean value has not changed, or mean value of the box is still or 368 grams. So there are different ways to have interpretation. Let me know if it is not clear. So this was the case of when sigma is known. Otherwise, we have seen all other cases where the sigma was unknown. And so go back here in the hypothesis testing. So Z test, remember, after reading the question, see, it is a 1 sample, 2 sample. or is the dependent sample, independent sample? When I mean, either it is a one sample or more than one sample. First you decide. If more than one sample, there will be two samples will be driven, will be drawn, two different data on the two different statistics will be given for one sample one and sample two. It will be clearly mentioned, and even the question looks like lengthy one, the bigger one. But in the one case, one single case, only one sample will be drawn and the sample statistics will be given. So that is the first step, to clearly see it is a one thing is like single mean or more than one mean. And the second thing is you have to understand, is it like sigma is given or not given? If the population standard deviation is not given, that is the clearly a case of t statistics. Then you have to apply everything using the degree of freedom, different way of calculating p-values. It's a critical way. Today we discuss about different varieties of the questions where we were dealing about the t-values, even the negative t-values. With what I said, like gradually you will improve in terms of your understanding, but keep working. This inferential statistics is really very meaningful stuff, like you are learning in a statistics. But if the case where plain population standard deviation is given, that means you have to apply Z test. And for the Z test, the calculation of p-value or the direct decision regarding area of rejection and not rejection is important. And so for that, you have to use this sort of analysis. Just now we have seen in the example. So what we have covered? We have covered the hypothesis testing for single population mean. Okay, so on Monday, let me show you from where we will start from Monday. It won't be a kind of repetition, whatever we have learned. So from Monday, it will be more hypothesis testing. So now we will have a kind of concept, something like dependent data, independent data, and proportion. So what is independent data? Like one sample is dependent on the another sample. I mean, two samples will be given, and before the exercise, your body weight, and after the exercise, your body weight. Do you think it is a one sample or two sample? It's clearly two sample. Is it a dependent data or independent data? In my case, just now I suggested you, like before the body weight and after weight. Do you think it's independent data or dependent data? So those kind of analysis we will do, and there will be a different sort of the two. I mean, different way of calculating. In one simple way, mean, the things were pretty easy, right? X bar minus mu, and it's. But for the two sample mean and all, it's a kind of duplication of analysis. So we'll have the different approaches for calculating, like doing. So still we are in the hypothesis testing. So that will be this. We will start with this one more and more in hypothesis testing next complete week. Even in that lecturing, we will discuss about, and in the tutorial, we will follow the week 10 tutorial material. And then in the second last one, the week 12, we will talk about the correlation and regression. That one will be the final chapter. Week 13 is very important. I'm keep repeating, in the week 13, in the lecture, we will have a complete revision of from beginning to end. We'll try to have in 2 hours. I will try my best to have a complete revision. So you must be there. And also in the week 13 tutorial, during the tutorial, I will bring some sort of exact model sort of set of question, which will appear in the exam. So it will be a kind of replica with the different values, different sort of exam. And we will try to do some of that some together. So that will be the week 13. So if you are like nervous about thinking about your exam, how it will go and all, please don't worry this time. Everything will be quite normal, and all the exercise this time, 95% of questions in the exam will be the same, which we have done in some of the slides and the tutorial. So that I'm assuring that one from my side. So no need to have any panic sort of thing. Just keep working, try to do your best. And as I said, I'm always there to with you guys. And this is a very unprecedented time, and you guys are really working very hard. I can see that even your enthusiasm level, everything is really good, like respected. So I'm really happy that you all are like keep engaging yourself and myself, having a good level of interaction. Everything is, I really appreciate all this. So please let me know if you individually, or even if you wanted to have a group discussion. We did it like some back in the last week, 4 or 5 students together. We had around 1 hour session, and then lots of questions one by one. It was shifting from one to another. So whatever you think, if you wanted to have a kind of 2 or 3 students together, you can just let me know. I will give you the time on Saturday and Sunday. And what is the idea? Overall idea is I am there with you all the time. Whenever you need any assistance, please let me know. I am honest from my side, and you have to be honest. And I believe that if you are honest and hardworking, things will be easy for you. You don't have to take any stress, especially in this subject of statistics. Let me know if you have any specific doubt or any specific issues. I will be staying here for another half an hour even today. So just stay with me and others. If you don't have any issues or any problem, just mark your attendance in the chat box and leave this platform.
Thank you, sir.
Thank you.
Thank you so much. Stay safe, and I'm here with you. So those who wish to continue, please, I'm there. Otherwise, you are supposed to leave. I'm stopping the recording now.